Okay, this tropical weather portion of your packet is at the back of your severe weather packet. So this is, I guess, technically screencast number 7 for Unit 8, Lesson 5, because this is part of our severe weather. All right, so we're going to start talking today about tropical weather. Okay, tropical weather, tropics, that would be the area that's close to the equator. Okay, the weather in the tropics is basically hot and humid. This is primarily due to the Earth receiving more solar radiation than it re-radiates back into space. Okay, they didn't mention this, but they're talking about the areas near the equator. Okay. So this is primarily due to the areas of Earth near the equator receiving more solar radiation than they radiate back into space. Because, for instance, near the poles, it we lose more energy than we get from the sun closer to the poles. But close to the equator, we get more energy than we lose, so there's an excess. All right, this excessive heating generates weather that can impact any other location on the globe. This energy imbalance drives the circulation of the atmosphere. So, let's read this real quickly. It says, near the poles, the sun's energy strikes the Earth at an angle, spreading the energy over a larger area than at the equator. Each square mile at the equator receives more energy than a square mile at the poles. So we get a surplus of energy at the equator. Surplus means extra. And we get a energy deficit closer to the poles. Okay. All right, this energy imbalance drives the circulation of the atmosphere, because if we've got overheating at the equator and underheating at the poles, we've got to redistribute the extra heat from here and get it closer to the poles. And we do that in a variety of ways, and tropical weather and hurricane systems, cyclones, things like that, is one way that we do that. There is abundant rainfall due to the rising air created by the sun's heating. This is talking about at the equator. And during certain periods, thunderstorms can occur every day. Okay, this is, remember, at the equator or near the equator. Nevertheless, the tropics still receive a considerable amount of sunshine, and when combined with the excessive rainfall, the tropics provide ideal growing conditions. So we have a lot of biodiversity at the tropics, a lot of different plant species, and ideal growing conditions for a wide variety of things. Because a substantial part of the sun's energy is used up in evaporation and rain formation, temperatures in the tropics rarely exceed 95 degrees Fahrenheit. So you might think it would be hotter at the equator than it is here, for instance, in Texas in the summer, but that's actually not the case. Why? Because a substantial part of the sun's heat energy is used up in evaporation and rain formation. Okay? At night, the abundant cloud cover restricts heat loss, and minimum temperatures fall no lower than about 72 degrees Fahrenheit. Again, this is all talking about at or near the equator. Okay, in the tropics. This high level of temperature is maintained with little variation throughout the year, meaning that you don't have like a really warm season and cold season. It's pretty much hot during the day and not so hot, warm at night. Okay? Therefore, the seasons are not distinguished by warm and cold periods, but by variation of rainfall and cloudiness. Okay, next we need to talk about the Intertropical Convergence Zone, which is usually abbreviated by ITCZ, because saying the whole thing is kind of a mouthful. The ITCZ appears as a band of clouds consisting of showers with occasional thunderstorms that encircles the globe near the equator. The ITCZ follows the sun in that its position varies seasonally. It's going to move north in the northern summer, and it's going to move south in the southern summer, or that's our northern winter. Okay, but it is always close to the equator. Okay, it exists because of the convergence of the trade winds. In the northern hemisphere, the trade winds move in a southwesterly direction, while in the southern hemisphere they move northwesterly. Okay, so remember from our global winds, we have trade winds in the northern hemisphere doing this, trade winds in the southern hemisphere doing this, and where they come together, okay, is the intertropical convergence zone. Okay. So it says the point at which the trade winds converge forces the air up into the atmosphere, forming the ITCZ, Intertropical Convergence Zone. Why is it called that? Because it's a zone where tropical air is converging. So it's the Intertropical Convergence Zone. All right, the next thing that we're going to talk about is tropical cyclones. Okay, a tropical cyclone is a warm core, low-pressure system without any front attached to it. So, for instance, it's not associated with a cold front or a warm front or anything like that. So, a tropical cyclone is a warm core, low-pressure system without any front attached that develops over the tropical or subtropical waters. So, right at the well, not right at the equator, but close to the equator or a little bit further away. Okay, and has organized circulation. Depending upon the location, tropical cyclones have different names around the world. In the Atlantic Ocean and in the Eastern Pacific Oceans, we call them hurricanes. The Western Pacific Ocean, they're usually called typhoons, and in the Indian Ocean, they're simply called cyclones. But they're all tropical cyclones, okay? What is a tropical cyclone? One more time. It's a warm core, low-pressure system without any front attached that develops over tropical or subtropical waters and has organized circulation. Okay, that is worth highlighting. Okay, and again, they go by different names depending on where you are in the world. We usually call them hurricanes because we are paying attention to things that are happening out in the Atlantic Ocean. They may come into the Gulf of Mexico, but they usually originate out in the Atlantic Ocean between Africa and North and South America. Okay.